We want to look at trig function values of angles of a given measure. It's not practical to know the trig function values for angles of every measure. Probably not even possible, definitely not practical, but there are certain ones that come up a lot. For example, 30 degrees, 60 degrees, 45 degrees. And we would like to know, say, the sine of 30 degrees, the cosine of 60 degrees, without having to grope for a calculator or fumble around for it. So we're going to look at 30 and 60 degrees here, the 6 trig function values for each of those. You might have noticed this is not, in fact, a right triangle. This is an equilateral triangle, or a reasonable facsimile thereof. Side lengths are 2. In any equilateral triangle, angle measures are 60 degrees. What I'm going to do with my lovely equilateral triangle is chop it in half. And by half, I mean exactly half. I'm cutting this top angle here in half, in 2 equal pieces. My triangle is in 2 equal pieces. So now I'm going to take just the right hand half here. This 60-degree angle at A is untouched by the chop. So it's still 60 degrees. The angle at B used to be 60 degrees, but I chopped it in half, so now it's 30. And I have a right angle down here, which is why I didn't have a C in my picture, because there's my angle C. Likewise, this side, the hypotenuse, AB, is untouched by my cutting the triangle in half, so it's still 2. My bottom side used to be 2, but now it's half of that. Now it's 1. And we can use the Pythagorean theorem to find the third side. We call it A since it's opposite side A. And we get 4 minus 1. A is the square root of 3. Now we have a right triangle, and we know all 3 side lengths, so we can find the 6 trig ratios of these 2 angles. So let's see. I'm going to start with the 30-degree angle, pi over 6. I'm going to call it pi over 6. It's 30 degrees. It's the same thing. And we can do this just the same way that you would work with any right triangle. If I'm talking about pi over 6, 30 degrees, my opposite side is down here at 1. My adjacent side is the square root of 3. So the sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent, 1 over the square root of 3. I am going to go ahead and rationalize this just because this is more often how we see it expressed. 1 over the square root of 3 is root 3 over 3. And then the 3 reciprocals, the cosecant is, well, the reciprocal of 1/2. That sounds like 2. The secant. And again, so it's 2 over root 3. I am going to go ahead and rationalize it just because that's the way we typically see it. So it's 2 root 3. That's not a 2. I can recover from this. There we go. 2 root 3 over 3. And the tangent, the cotangent is adjacent or opposite over adjacent. I'm going to try that again. The cotangent is adjacent over opposite, which is root 3. There are 6 trig functions for 30 degrees pi over 6. This same triangle we can use for 60 degrees or pi over 3. That'll be A. I'm going to just draw it again. Hasn't changed. That side is still root 3. I'm just looking at the other angle now. 60 degrees, I'm going to call it pi over 3, but 60 degrees, same thing. So the sine, my opposite and adjacent sides have now changed roles. Opposite side for angle A is root 3. Adjacent side for A is 1. So sine of pi over 3, sine of 60 degrees is opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent is opposite over adjacent, root 3 over 1, and the reciprocals. So again, we'll rationalize. This is 2 root 3 over 3, the secant, 2 over 1, which we'll just call 2, and the cotangent. Again, we'll rationalize this one to get root 3 over 3. And there are 6 trig values for 60 degrees or pi over 6.